We are moving into section 6.7. There's this section and one more left in the chapter. And I think what you're going to notice today and tomorrow is as the chapter goes on, the sections actually get a little bit easier, which I know is not usually normal, usually kind of builds up more and more difficult. I hope and I think you're going to find these last two sections to be some of the easier sections in chapter 6. So section 6.7 is about inverses. Now, you already know about inverses from a basic, not even algebra, but like arithmetic standpoint. You should know that the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of square rooting is squaring. It's the basic operations that you do every time you solve an equation to undo the other. So basically, we call them like opposite operations. That's what an inverse is. We're going to really focus today on how do we write inverses? How do we find them graphically? How do we know if inverses are functions? So we're going to kind of dig a little deeper into inverses today. So if we have an original point or original relation, a comma b, the inverse is just switching it. So if I want to go from an original point, an original equation to the inverse, you're going to switch all your x's and y's. And I'm going to show you exactly how Delta Math's going to ask you to do that in a second. Now the notation, this might be something you're not as familiar with. The notation for writing an inverse equation is using this little -1 notation, f of -1. That means f inverse. It is not an exponent. It is the notation used to say that something is an inverse. It's saying that if a function pairs b with a, then the inverse f with this -1 will pair a with b. So you'll see that show up when they're asking you to find or use inverses. When we have a table of data, if we want to find an inverse of it, so here's a table of data, and again, they're just kind of random points. If you were asked to write the inverse of that, so they're calling this the s function, so I'm going to put a little s of the -1. All that you would do with your table is just flip-flop the columns. So your x now has all your y values, so -1, 0, 2, and 3, and then your y would all be your x values. We just flip-flop all of that to get those new points. Here's what it looks like when you graph, and I think it's helpful to graph it in like two different colors. So I'm going to graph the original relation in red. So I've got let's see, 0, -1 is down here. These points are a little bit big. Trying to get them to be a little bit smaller. And then 2, 0 is right here. I want it to actually be a little bigger than that, somewhere in the middle here. And then 3, 2 is here. And then 4, 3 is here. So those are all of your original points. And then I'm going to put the inverse one in blue, just so you get to see it show up just a little bit easier. Hold on, let me get this to be this little bigger. I want this to be bigger. So my inverse points are -1, 0, which is here, 0, 2, which is here, 2, 3, 2, 3, which is here, and then 3, 4, 3, 4, which is here. And here's what you're going to have happen. When you graph these points, so when you graph your original set of points and your inverse set of points, you're going to see a visual relationship. You're going to see a reflection, so using it like a word from geometry class, you're going to see a reflection over the line y equals x. So that is your line of reflection or your reflection line. And that is true for anything, any graph or any set of points that are inverses, is you will see that reflection where every point on one side of the line will have like its partner point on the other side. This is called the identity line, y equals x, because it's the one place where all the y's and x's are identical. If anything falls on that line, it's going to be the same for the original and the inverse. So the points on that line are like the points 2, 2, 3, 3, 4, 4. So they would be the original and the inverse identically. So let me show you what Delta Math does, because I think it's kind of interesting to see what they're going to ask you to do. So Delta Math is going to give you, instead of a set of points, they're going to give you a graph, and they're going to ask you to come up with what some of the inverse points would be so we could get an idea of what the picture of the inverse looks like. And they will tell you that until you do 5 points, they're not going to consider it an acceptable answer. So here's what this looks like. So I'm going to look at this graph, and I'm going to look for a point that's very easy to identify. Like, for example, I can tell from the point, let me kind of write on this for a second. Like this point right here to me is pretty obvious. That's the point 1, 4. So that means I want to plot the opposite. I want to plot 4, 1. in order to get the inverse point. And I'm going to do that with like any point that to me is easy to identify. So like this point is the point -3, 6. So I'm going to look for the point 6, -3. And same thing here. Again, pick points that to you look like they're whole numbers. So I'm going to kind of like circle those points and then plot them. So I'm going to take my writing off the screen here for a second. So I said that 1, 4 look like it. So I'm going to go to 4, 1, and I'm going to put a point there. And then it looked like -3, 6. So I'm going to go to 6, -3, and put a point there. If you put a point somewhere and you don't like where you put it wrong, you just click on it again and it'll go away. -3, 2 looked like a point. So I'm going to go to 2, -3. What else we got here? Looked like -8, 1. So I'm going to go to 1, -8. And it also looked like -8, 7. So I'm going to go to 7, -8. And you'll notice once you get that 5th point there, it's going to connect the dots for you. You don't have to connect the dots and try to make it really look pretty. They'll make it look pretty for you. You'll also see that reflection line that we just talked about. So you can see that y = x line. So you can see if you put a mirror on that line and flipped over this like new parabola that you just drew, you would get that original graph. So that's what they're going to ask you to do. So instead of giving you a table, they're going to give you some sort of picture. You're going to pick 5 points on the picture that look easy to identify and then plot the inverse point. So switch the X and Y. Once you get that 5th one, it will connect and then it will let you submit. It doesn't let you submit until you get all 5 and until it connects the dots. And it will even go here and tell you, here's a bunch of points you could have used. Obviously, we used 5 of them, and here are those points. So that's what they're going to expect you to do on Delta Math with this.